Hey folks, welcome back. Today we are going to continue on with our study of magnetism as we kind of find out a little bit about where magnetism is, or what it is and where it comes from. And today we're really going to dive into a little bit more about the discovery of how electricity and magnetism are tied together. As we'll see that you don't have one without the other. Famous experiment by a guy by the name of Hans Christian Ørsted was kind of credited with making this tie, making this discovery that electricity and magnetism were really one in the same force. He had a compass and he brought it near a wire that was running an electrical current, and he saw the compass needle get deflected. And so we'll see a little demonstration of that a little bit later. But what he showed then was that moving electrical charges create a magnetic field. And as we see, we just don't have one without the other. And so that's why electromagnetism, those two terms are kind of thrown together in one force we call the electromagnetic force. We were also able to show that when I change the direction that the electric current is flowing, it also changes the direction of the magnetic field. If you remember, we kind of talked about magnetic field lines running from north to south and so forth. Well, there's something called the right-hand rule, or at least the first right-hand rule. There are multiple ones, but we're just going to worry about the one here. And that if you take your thumb and point it in the direction that the current is flowing, your fingers are going to wrap around, as if you're wrapping around the wire, in the direction of the magnetic field. And it's kind of a handy way to make that work. Now, when I have those magnetic fields being created by a current of electricity flowing through a wire, one of the things that we discovered is that what you can do is you can essentially add them up. And if we start to loop wires, make coils of wire, those magnetic fields that form from the current flowing through those wires, they start to multiply. And the magnetic fields combine to form stronger magnetic fields. Well, a device called a solenoid is just that. It is a coil of wire that runs an electric current through it. And when you do that, you create a stronger magnetic field. The more loops that you have, the stronger the magnetic field you're going to be able to make. You can make it even stronger by taking that solenoid and dropping a little what we call a ferromagnetic core in there. In other words, usually it's just some piece of iron that you're going to put in there, and you're going to wrap those coils around that piece of iron. Okay, and what you form then is what we call an electromagnet. Maybe some of you have made these before. We're going to show you a little demonstration in just a bit. But having an electromagnet is important because now suddenly we can take that magnetism and we can do a number of things with it. We can control it. We can change the direction of the current, which also changes the north and south poles of the magnetic field. We can turn the magnetism on and off just by turning off the electricity. And we can also increase or decrease the force of magnetism based on either the number of coils or also by increasing or decreasing the amount of current that's flowing through there. So we're going to take a look again at that relationship between electricity and magnetism, and we're actually going to try and reenact Hans Christian Ørsted's famous experiment that tied the two together. You see the setup here. I've got myself just a 9-volt battery, one you might have laying around the house, and that is hooked up to a wire. And over that wire, I'm just going to lay my compass. And the idea then is that when I start running a current through this wire, we're going to see how it affects that compass needle. And when I touch the terminals, we see that compass needle jump. And you might not think that that's so extraordinary. I might say, well, what's the big deal about making a little compass needle move? Well, again, when Ørsted was approached with that same response, he said, well, what is the value of a newborn child? Because here was suddenly a discovery where we were connecting these two things and we had no idea what the possibilities were. Well, nowadays we live most of our life very much tied to this whole concept. If we slide over here again on the table, again I've got a little voltage source, got a couple of AA batteries hooked up here, and I've got just some wiring, and you'll see this wire is hooked up to a wire that is wrapped around a nail. All right, and so again we know that that current is going to create a magnetic field. Well, if I wrap it around enough times, I'm going to have those magnetic fields build up on each other. And so now, when I take my switch and I turn it on, I create what's called an electromagnet. Now, if I turn it off, the electricity turns off and the magnetism turns off. And, you know, of course, I can pick up a paper clip with a permanent magnet as well, but now all of a sudden that's stuck on there. And I don't have any control over how much magnetism there is. But with an electromagnet, I can turn the magnetism on, I can turn it off, and depending on how much current I run through here and how many loops of wire I have, I can strengthen or weaken that the magnetism that's involved. So in summary today, what we covered, we saw that relationship between electricity and magnetism, and how they go back and forth between one another, and that's what we call electromagnetism. We got a little glimpse of Ørsted's famous experiment. We learned a little bit about what we call the right-hand rule. We learned about solenoids and electromagnets. What I want you to do is also then watch a little crash course physics number 32, just the first 3 minutes and 50 seconds of it before you do your quick quiz. It does a nice job kind of summing up a lot of what we did and covering a couple things in addition as well. A reminder, you do not have distance learning on Friday, May 1st or Monday, May 4th. So enjoy your nice long weekend, and we'll see you next week.